Alright, okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning. So today we will continue our class online. This will be the last class lah for this subtopic, which is work and energy. So in the next class, we will go into the last subtopic of this chapter, which is impulse and momentum. So today I will show you a few more example questions. But before that, let's recap what we have learned before. So basically in this subtopic, the main equations that we will use is the principle of work and energy. Okay. So I have explained in the previous class that the principle of work and energy involve this equation, which is T1, that is the initial kinetic energy, plus the total work done. This is not U1 minus 2. This is U1. This means that the total work done to move from position 1 to position number 2. So basically this says that U1 to 2. Bukan 1 minus 2. So this is basically total work done lah to move from the initial position to the final position. And then we have equal to T2, which is the final kinetic energy. So if you recall, kinetic energy, right? Kinetic energy is calculated by the general equation will be T equals to 1 over 2 times mass times Vg square plus 1 over 2 times the Ig n times omega square. Right? So this is the general equation for kinetic energy. All right. So if we have rotation only, for rotation, we can simplify the equation and calculate the kinetic energy about the center of rotation, the fixed point, which is point O. So we can use the equation T is equal to 1 over 2 times IO. Okay, this is no longer Ig, IO times omega square. So this is this can only be used for the case of rotation. Okay, for general plane motion, we can also simplify the equation. You have to calculate the mass moment of inertia or the kinetic energy at the location of IC. So the equation will be 1 over 2 times IIC times omega square. Okay. So these are three equations lah, that you can use to calculate kinetic energy, right? To calculate kinetic energy. And of course, when you want to calculate the mass moment of inertia about other points, other than the mass moment of inertia about center of gravity, then you have to use the parallel axis theorem lah. Okay, the parallel axis theorem. The parallel axis theorem, which is IO, for example, is equal to Ig plus MD square. Right? So this is the parallel axis theorem. So these are all what you need to know for kinetic energy. And then we also learn about the work done. Okay, we also learn about the work done. All these are needed in the equation of principle of work and energy lah. So number one, we have work done by the force. Work done by the force, which is given by UF is equal to the force itself multiplied with delta S, which is the distance traveled. The second one, we have the work done by the weight. Okay, the work done by the weight only happens when there is a change of height. So if the object is moving from bottom going up or from top going to bottom, then you have work done by the weight, which is given by UW is equal to negative W times delta Y. Delta Y is also is similar to delta S, but delta Y is in Y axis lah. Okay. Then number 3, we have the work done by the moment. Okay, if we have rotation, um, rotation, normally the work done by moment involve rotation lah. And then there is a moment applied. So you can calculate work done by moment, which is UM is equal to the moment itself multiplied by delta theta. Delta theta is the change of angle. So, and then remember, theta here must be in radian. Okay. And the last one, the work done that we have learned is work done by the spring. Okay, you have work done by the spring, which is given by US is negative 1/2 times K, which is the spring constant. Normally it is given in the question, and then multiplied with S2 square minus S1 square. And I have explained in the class that both S2 and S1 is the elongation of the spring. This is the elongation, spring elongation, right? Okay. So these are all that we have learned for the subtopic of work and energy. So let's go to an example question. Okay, we have a question here. 30 kg rod is released from rest when theta equals to 0. Okay, when theta equals to 0. So you can understand that when theta equals to 0, it means this position. Okay, this is the position of the rod initially when theta equals to 0, when it is released. Okay, and we want to determine the angular velocity of the rod when theta equals to 90 degrees. The spring is unstretched when theta equals to 0. Okay, so the first thing that we need to do is to draw the position of the object. Okay, so the position of the object we can draw over here. So basically we have when theta equals to 0 is somewhere here, right? That is the initial position of the rod, right? And we have the rod is connected to a spring, so there will be a spring here. Oh, sorry. There will be a spring at the end here, like that, and it ends there. Okay, so this is basically the position number 1. Okay, you can write down that this is position number 1. Okay, when theta equals to 0. And what we want to find is angular velocity, which is omega, when theta equals to 90 degrees. So when theta equals to 90 degrees, where is the position of the rod is basically vertical position lah. This is the position of the rod when theta equals to 90 degrees. Right. So let's move this a little bit. Right. Okay. So this is the position of the rod, position number 2, and you have the spring now. Spring is at the end of the rod, and it should be stretched to here, right? So that is the illustration lah of the first position and also the second position of the rod. Okay, that is the first step, that you draw initial position and the final position. The next step is to draw the free body diagram. Okay, you draw the free body diagram on the first position. So this is the center of gravity somewhere in the middle of the rod. So there must be weight mg pointing down here. Okay. In the second position also, we have mg over here, right? And then we have the reaction force at the pin, but the reaction force, we have identified that the reaction forces are not doing any work. Okay, we have reaction force here. So we can write here reaction forces at the fixed point are not doing work. Are not doing work. Okay, so for this case, you do not have to draw lah the reaction forces sebab dia tak buat kerja. Okay, so if we look here, if you draw the line at the first position and the line at the second position, we can see that there is a change of height. There is a change of height. So if we draw a line here, all right, so we can see that the center of gravity is changing. The height of the center of gravity is changing. So this basically will be the delta y. This will be delta y. Okay. So that is the first force. That is the first work done that we can calculate. So from here, let's calculate the work done by the weight. We have UW. UW is equal to minus W times delta Y. And delta Y here, if we look at the figure, the total length of the rod is 1.5 meter. This is 1.5 meter. So basically, delta Y should be half of the length of the rod, and it should be 0.75. Okay, so if we go back, the mass of the rod is 30 kg. So UW is basically minus 30 kg times 9.81 multiplied with 0.75, and we can see that delta Y is pointing downwards. So this will give you a negative value, minus 0.75. So in the end, we will have a positive value of work done by the weight. So therefore, UW is equal to 220.7 joule. Okay, this is the work done by the weight. Okay, so we have the first work done by the weight, 220.7. Okay, the second work done that is happening here is the spring, because we have the spring here at the first position, and then the spring is clearly stretched in the second position. So bila spring ni ada stretch or the spring is compressed, there must be work done by the spring. Okay, and we have a clue here given in the question. It says the spring is unstretched when theta equals to 0. So this means that at this position number 1, this is unstretched. It means that S1 is equal to 0 lah, because it is unstretched. But we need to know what is the unstretched value. Okay, we know that the length of the rod is 1.5 meter. This is 1.5 meter, and from the figure here, we can see that this is 2 meters. Okay, the total length from O to the spring punya fixed point. So we know that the unstretched length here, unstretched length of the spring is, maybe I write it up here. Let's bring this over there, and then we can write here the unstretched length of the spring is basically 0.5 meter. Okay, the unstretched length. So this, what this is the unstretched um, unstretched length of the spring. Okay, so we have S1, which is equals to 0. Now we need to find S2. And please remember that this length of the spring is not S2. This is L2. Let's call this L2. The length of the spring at position number 2. Tapi to find S2, we need to find L2 and subtract with the unstretched length, which is 0.5. So that will be the value of S2. So how do we find L2? If you can imagine a triangle here, we have a triangle here. Okay, so we can find the length of L2 by taking out this triangle. So let's do that. Let's take out the triangle. We have a triangle like this. Okay, something like that. Okay, so L2 is the hypotenuse, sorry. L2 is the hypotenuse, and we have the left side is 1.5 and the top is 2.02 meters. Okay, so we can use the theorem Pythagoras here to get the value of L2. So L2 is then basically 1.5 square plus 2.0 square and then square root. Okay, so we will get the value of L2, which is 2.5 meter. 2.5 meter. This is the value of L2, and therefore we can get the value of S2. S2, the elongation of the spring at position 2, which is 2.5 meter, L2 minus the original length or the unstretched length, which is 0.5. So minus 0.5 here. And we will get the S2 equals to, we will get S2 equal to 2 meter. L2, S2 equals to 2 meter. Okay. This is important apa ni? Important parameter lah to calculate the work done by the spring. Okay, we have S1 and S2. S1 equals to 0, S2 equals to 2 meter. Okay, then we can go and calculate US. Okay, US, the work done by the spring, which is minus 1/2 times K. K is given here, 80 Newton per meter. So multiply with 80. Okay, 80 Newton per meter. And then multiply with S2 square. So you have here 2 square, S2, minus S1 square, which is 0. Okay. So this will be US. So we have then US is equal to minus 160 joule. Okay, so this is our US, right? So we have calculated both kita punya work done. Okay, let's make this a bit bigger. Okay, so we have work done by the weight 220.7, and we have the work done by the spring minus 160. Okay, now remember our ultimate equation is T1 plus total U to move from 1 to 2 is equal to T2. Okay, so basically we have already calculated U total U. So we have two work done here. So now we need to find what is T1. So look at the question, and it says here, released from rest when theta equals to 0. So that is a clue, so that we know T1 is equal to 0 because it starts from rest. Okay, starts from rest. Okay. So we have our T1 already. T1 is equal to 0. All right. Then the next part is to find the value of T2. Right. And this is clearly a rotation problem. We can see that it is rotating about the fixed point O. So we can use the apa ni, kinetic energy for rotation lah. Therefore, T2 is equal to 1/2 times IO times omega 2 square. So what we want to find in this equation is basically this omega 2. Okay, this omega 2 is what we are interested in for this problem. So before we can proceed, we need to calculate IO. So we know to calculate IO, we need to use the parallel axis theorem. IO is equal to IG, right, plus M times D square. Okay, I repeat again, what is the meaning of D? D is the distance between O to G. Okay, this is the D, distance from O to G. So if you look here in the figure, point O is here, point G is in the middle of the rod. This is point G. So basically, D is half of the length of the rod lah, which is 0.75. This is D equals to 0.75 meter, right? Okay. Before we can calculate IO, we also need the value of IG. So this is a slender rod. Okay, a rod, sometimes it is written as rod, sometimes it says slender rod. Kalau dia tak bagi radius of gyration, which is K, you can simply assume that this is a homogeneous punya object lah. So for slender rod, we have IG is equal to 1/12 times the mass times the L square, L of the rod. So you have here 1/12 times 30 kilogram, the mass of the rod, times 1.5 square, the length of the rod. Okay, which will give us IG is equal to 5.625 kg meter square. This is the IG lah. Okay. So then once we have IG, we can substitute in the IO punya equation. IO is equal to 5.625 plus the mass 30 kg times D, which is 0.75 square. So we will get the value of IO is equal to 22.5 kg meter square, right? Then we can substitute in the equation of T2 here, which is 1/2 times IO is 22.5 times omega 2 square. So we have T2 is equal to 22.5 divided by 2, you have 11.25 omega 2 square. Okay, omega 2 is the one that we want to find. Okay, so then we have all this. We can then substitute in this equation lah. Can then substitute in this equation. Let's copy this equation and put it in the next page. right? Okay, so this is our equation. We have T1 equals to 0. So T1 is 0 plus the total work done. We have 220.7. Okay, so 220.7. And then we have another work done, which is minus 160 joule. So minus 160 joule, point, no, there's no point, equal to T2, which is T2, let's highlight T2 here, there, 11.25 omega 2 square. So 11.25, and what we want is omega 2 square, right? So from here, you can solve the equation for omega 2. Remember, there is a square over there. You need to do a square root to solve it. So you will get omega 2 is equal to 2.33, 323. 323. The unit is radian per second. So this will be the final answer. All right. Okay. Any question on this example? Do you have any question before I proceed to the next example?
Yes, sir.
Okay, so if there's no question, let's proceed to the next question. Similar problem. We have an object and also a spring. So let's read the question. 30 kg rod is released from rest when theta equals to 45 degrees. Okay, when theta equals to 45 degrees, it is released from rest. So let's draw that. So 45 degrees is somewhere, I'm just going to draw a line to represent the rod. So this is the rod at the first position. Okay, and we have apa ni, the spring also. So here the spring will be like this. Okay, so this is the first position, 45 degrees. Okay, determine the angular velocity of the rod when theta equals to 0. So theta equals to 0. What happens to the rod? Let's bring this bit here. Okay, when theta equals to 0, what happens to the rod when theta equals to 0? Which where is the position of the rod when theta equals to 0? And can anyone tell me? When theta equals to 0, the rod is vertical or is the rod horizontal? Which one?
Horizontal.
Horizontal, correct. So when theta equals to 0, the rod is then become the, okay, this is A over here. This is point A. Here is point B. Okay. So when theta equals to 0, point A is now down here. This is point A when theta equals to 0, and point B is then somewhere here. Okay. So this is the new point A at position 2, and this is point B at position 2. And you have the spring now all the way along the rod. That is the spring lah. Okay. So let me ask you, what is the type of motion of this object? Is it rotation? What is the type of motion?
Translation.
Translation? Are you sure?
GPM.
Yes, this is general plane motion. If you can look closely, initially the object is here, and then the object is down here. So there is rotation involved, and also there is point B here, translate. Point B is translating to this new position of point B. Point A is translating to new position of point A here. So A and B is translation, but the rod itself, dia ada rotation. Daripada the rod tu berada dalam keadaan 45 degrees and it rotates to horizontal punya position. So this is the general plane motion lah. This is GPM problem. Alright. Okay. So what else we have the information? We have the spring is unstretched when theta equals to 45 degrees. Alright. So let's write down where is the initial position. So this is the first position, the black color, and the blue color is the second position. Okay. So now let's draw the free body diagram. So we have center of gravity at the middle of the rod. So there will be mg pointing down. Okay. And at the second position, you can see that mg is now here. So there is definitely change of height here. So there is work done by the weight. And then we also have the work done by the spring. Okay, the spring is at 45 degrees. It is initially unstretched. Okay, we can read here, spring is unstretched when theta is 45. So initial at position 1, the spring is unstretched. Now we need to find what is the S2 lah, when the rod is at position number 2. Okay. So let's calculate the work done by the weight first. Okay, so the work done by the weight, obviously let's draw a line here. Let's draw a line so that we can find delta y. Delta y is basically daripada position yang pertama turun ke bawah. This will be the delta y. Okay, this is delta y. Alright. Okay. So, how do we find delta y? How do we find delta y? Any idea? How do we find delta y punya value?
Triangle.
Okay. Triangle, yes. Always look for a triangle. So, if you look closely, you can get a triangle daripada sini ke sini and like this. So, the yang tegak ni is delta y. Okay, so let's take out that triangle. Let's take out that triangle and put it here. Okay. We have triangle like this. Okay. So basically our delta y is here, right? Do we have the length of the hypotenuse? Berapa panjang hypotenuse?
0.75.
0.75, because the total length of the rod is 1.5. So from B to point G is 0.75, and so does this hypotenuse is 0.75. What is the bottom? Oh, you don't need the bottom part. It's okay. You don't need the bottom part because we know the angle here is 45 degrees. We know the angle is 45 degrees. So can we get delta y when we have the hypotenuse and the angle? Macam mana nak dapatkan delta y?
Sine.
Sine, yes. So delta y is basically 0.75 multiply with sine of 45 degrees. Okay, sine of 45 degrees. So therefore, you will get delta y is equal to 0.5303. 0.5303 meter. This is the value of delta y, right? So once we have the value of delta y, kita boleh calculate the work done by the weight. So UW is equal to minus W times delta y. This is equal to, what is the weight? 30 kg rod. So we have minus 30 times 9 times 9.81 times 0.53 ni going downwards, so it will be negative 0.5303. Okay, so we will have a positive value of delta of UW, which is 156.0.1 lah, 156.1 joule. Okay, so this is the value of UW. All right. Okay. One part is settled. Now we need to calculate the work done by the spring. Okay, let's write down the equation. First, we have US is equal to minus 1 over 2 times K. K is given 300 times S2 square minus S1 square. Remember, S is the elongation. Okay. So, if we look at the question here, it says the spring is unstretched when theta is 45 degrees. So, initial position, the spring is unstretched. Straight away, we know that S1 is equal to 0. Okay. But we need to know what is the length of S1. Sebab nanti kita akan find the length of S2 and we need to find the length, the original length to subtract, and then we can get the value of S2. Okay. So again here, if we zoom in, you can get a triangle lah from here. Kalau nak lebih clear, kita refer pada figure yang di atas ni. This is a triangle. Okay, this is a triangle. Okay, so what we want now is the bottom part. This is the length of the spring, original length. And we know the angle theta is 45 degrees. Okay, so let's take out that triangle juga to help us. So we have a triangle like this. Okay, now we know that this is 1 point, we know that this is 1.5, the hypotenuse. Apa yang kita nak is this one. This is L1 lah, L1. Okay, this is L1. And we know that this angle is 45 degrees. So kalau tadi kita nak dapatkan vertical length, kita guna sine. So this in this case we can use cos lah. So L1 is equal to 1.5 multiply with cos of 45 degrees. Okay, cos of 45 degrees. So we will get the value of L1, which is 1.0607 meter. So this is the original length of the spring ataupun unstretched length lah. This is original length of the spring. Original length. Alright. Okay, so now we have L1. Sekarang kita perlu cari L2. Okay, if we look at the question here, the figure here, L2 is this length lah. Okay, this is the length of the spring pada position yang kedua. So you should get L2 from here. This is L2. Panjang spring pada keadaan pada position yang kedua. So what is the value of L2? What do you think? Apa value L2? Anyone?
1.5 meters.
1.5, exactly. L2 ni adalah sepanjang sepanjang rod tersebut, which is the total length of the rod is 1.5. So L2 is equal to 1.5 meter lah. Alright. So when we have L2 and the original length, we can then calculate S2, the elongation at position 2, is equal to L2 minus L1. Okay, L2 minus L1, which is 1.5 minus 1.0607. Therefore, we get S2 is equal to 0.4393. Okay, 0.4393 meter. All right. Okay, so we can substitute this value in the US punya equation. So here, this will be equal to minus 1 over 2 times, what is the K? 300 Newton per meter times 300 times 0.4393 square minus 0. Okay, S1 is 0, S2 is 0.4393. So we will get US is equal to minus 28.95 joule, right? So this is the value of US. All right. Okay. The next clue is we have here the rod is released from rest. Okay. Remember kita punya apa tadi? Kita punya equation, principle of work and energy is T1 plus total work done is equal to T2. So total work done kita dah ada 156.1 and minus 28.95. And from the question, we know that T1 is equal to 0. So write it down. T1 is equal to 0. Okay, because it starts from rest. Starts from rest. Okay. Now we need to find T2. Okay. So T2 is, this is a general plane motion. Awal tadi kita dah identify that this is a general plane motion. So we can use the long equation, which is 1 over 2 mv square plus 1 over 2 ig omega square. Or we can use 1 over 2 times IC times omega 2 square. Okay, so I will show you this. I will show you this method where we use IIC. But to use IIC, we need to identify where is the location of IC. Okay, how do we identify the location of IC? All right, let's take to find the location of IC. We will refer to the second position, which is the blue color. Why? Because we are currently calculating T2. Now we focus on position number 2. So let's focus on the blue color, position number 2. Okay. Remember, how do we find IC? We need to draw, or we need to identify the direction of velocity. So first, let's identify direction of velocity of point A, VA. VA is pointing in which direction? VA ni daripada atas, dia turun bawah, dia point ke arah mana? Ke bawah lah kan? So VA is pointing down this direction. This is VA. Right. What about VB? VB is pointing in which direction? Point B is moving to the left. So VB is then pointing to the left. This is VB. Okay, so VA pointing down, VB pointing to the left. So to get the value of IC, kan kita kena draw 90 degrees line untuk kedua-dua velocity vector. So untuk VB, when you draw 90 degrees line, this will be 90 degrees line of VB. Untuk VA, when you draw 90 degrees line, this will be 90 degrees line of VA, and it can go straight to ke hujung ni lah, ke hujung. Okay. That is the 90 degrees line. So where do you think the intersection between 90 degrees line of VA and 90 degrees line of VB? Where is the intersection point?
At B.
At B, exactly. So at point B ni sebenarnya intersection point. So this is basically at point B here. This is the location of IC. Okay, location of IC is at point B. All right. So we have identified the location of IC. Now we can calculate apa ni? The IIC lah. Okay. So IIC sama juga, we need to use the parallel axis theorem. IIC is equal to IG plus MD square. So why do we need the location of IC tadi? Because D, to get the value of D, is the distance from IC to G. This is the value of D. So now that we already know the location of IC, location of G is here at point MG, tengah-tengah. This is point G. So the location of IC is at point B. The location of G is in the middle. Therefore, the length D is basically is equal to half of the length of the rod juga lah, which is 0.75. Okay, so that is why we need to know where is the location of IC, because to find the value of D. Okay, so coming back to this parallel axis theorem, before we can proceed, we need to calculate IG first. Okay, we need to calculate IG, which is, this is a rod. Okay, this is also a rod, so 1/12 ml square. All right, so 1/12 times 30 kg. L is 1.5 square, so we will get 5.625 kg meter square for IG, and this value then we will substitute in the parallel axis theorem, so which will be 5.625 plus 30 times 0.75 square. Okay, so we will get the value of IIC, which is equal to 22.5 kg meter square. Okay, sama macam contoh tadi lah, sama macam yang sebelum ini. Okay, so then we will continue over here to get the value of T2. Okay, to get the value of T2, so T2 is then 1/2 times 22.5, which is IIC, times omega 2 square. So we will get T2 is 11.25 omega 2 square. All right. So when we have all this, we can then substitute. Let's go to the next page. Okay, this is our equation. All right. So we can substitute T1 is equal to 0 plus, all right, work done, we have 156.1 joule, and then we have minus 28.95 that is the total work done, is equal to T2 is 11.25 omega 2 square. Okay, 11.25 omega 2 square. And therefore, we can calculate the value of omega 2. Remember to square root it. So finally, you will get omega 2 is equal to 3.362 radian per second square. And this will be the final answer. All right. Any question on the second example? Ada berapa soalan? Okay, if all clear, let's move to the last example for today lah, and also the last example for this subtopic, work and energy. In the next class, we will continue with impulse and momentum. Okay, this will be the last example. Before I continue, I forgot to inform in the group that I have uploaded assignment number 2 in Kalam. So for those yang belum buat, please do so. I will give time until Sunday ni, 1 whole week ni, for you to submit assignment number 2. That's one thing. And then on Wednesday, I have to cancel the class on Wednesday because I need to go to KL. We will do a replacement class. I'm not sure yet when is the time. Maybe we will do it Friday night. Friday this week lah. Friday this week at night. So we will have 1 hour or so class macam pagi ni lah, online. And then on Monday we will have class as usual. Monday next week, week 14, week 14. And then also Wednesday next week we will have class as usual, and we will also have quiz 3 lah on Wednesday next week. And your test 3 will be on Thursday next week, Thursday night, 8 to 10. Okay, so that is some information that you need to know lah. So this coming Wednesday, esok lusa ni kita tak ada kelas, but I will do a replacement class so that we can finish the impulse and momentum punya subtopic. Okay, let's focus on the last example here. Again, we still have a slender, it says here slender bar. So sama lah, slender bar, slender rod, it's the same thing. Okay, slender bar AB is horizontal and at rest, and the spring is unstretched. Okay, so meaning that pada keadaan sekarang ni, spring is unstretched, and you can see here the length of the spring dah bagi pada unstretched. So 1.5 meter is the unstretched length. So unstretched length, kita boleh tulis terus, unstretched length of the spring, unstretched length is 1.5 meter, right? Okay, this is important. Ni slightly different soal dia. Determine the stiffness K. Okay, dia tak bagi apa spring constant K ni. Sebelum ni semua dia bagi, but now dia tak bagi. We need to determine the stiffness K of the spring so that the motion of the bar is momentarily stopped when it has rotated 90 degrees after being released. Okay, apa yang you faham tentang ayat ini? What does it mean? The spring is released from rest. Okay, so dekat atas ni dah ada satu clue. At rest. Masa dia release at horizontal, the rod is at rest. Lepas tu, dia release, and after it has rotated 90 degrees, the bar, the rod is momentarily stopped. So apa maksud dia? What do you understand by this? What do you understand by this?
The weight is equal to the the work done by the spring is equal to the work done by the weight.
Sorry. The what?
The work done by the spring is it cancels out the work done by the weight.
No. Okay, let's go back to the first one. The slender bar is at rest. Initially at rest. So what is T1? T1 is 0, right? Because it starts from rest. Starts from rest. Okay. So let's draw here lah. This is position 1. Okay, let's use blue color to indicate that this is position number 1. So what is position number 2? Position number 2 now, the rod is now here. It has rotated to 90 degrees. This is the rod now. And what happens to the spring? The spring is now stretched to here. Okay, this is position number 2. Okay, so my question is, at position 1, initially, the rod is at rest and it is released. So T1 is equal to 0 sebab dia mula-mula at rest, tak bergerak. And then dia rotate. Bila sampai 90 degrees, because of the spring tu menarik, spring is pulling. Bila dia sampai 90 degrees, it is momentarily stopped. So what is T2?
0.
Yes, T2 is also 0. Why? Because it has stopped. Okay, dia tulis kat sini, the object stop at T2. Lepas tu dia akan patah balik lah. Tapi kita tak concern pasal dia patah balik tu. Kita nak tahu keadaan dia pada position 1 and also position number 2. So both T1 and T2 are 0 in this case. Okay. So now what we have is we need to calculate the work done by other forces lah. So if we draw the free body diagram, if we focus here, this is the center of gravity. So you will have mg here, and point G is now moving down here. So definitely you will have work done by the weight. Okay, you will have work done by the weight, right? So this will be delta Y. Okay, this will be delta Y. Sama saja macam tadi. So can you guess what is the value of delta Y? Delta Y is equal to?
0. 1.
Yes, delta Y is 1 because the length of the rod is 2 meter. Delta Y is half of that is 1 meter. Okay, so good. Delta Y is 1 meter. So basically kita akan ada work done by weight and also work done by the spring. Okay, tapi slightly different soalan ni because dia tak tanya angular velocity, dia tanya what is the K, stiffness K. Okay, let's calculate the work done by weight first. So we have UW. UW is minus W times delta Y. Okay, so this is equal to the weight is 6 kg. Okay, so you have minus 6 times 9.81 times delta Y is minus 1. Okay, remember minus is there because delta Y is pointing down. Okay, so we have UW is equal to, what is UW? Minus 6 times 9.81 times minus 1. Okay, so you have 58.86 positive, 58.86 joule. So this is UW. All right, we have 1. Okay, now we need to calculate the work done by the spring. Okay, so US, work done by spring, is given by minus 1 over 2 times K, which is unknown, times S2 square minus S1 square. Okay, by reading the question, what is the value of S1? What is the value of S1? Bila dia kata the spring is unstretched pada position number 1. S1 is?
0.
S1 is 0 because pada awal, initially, the spring is not yet stretched. So S1 equals to 0. Alright. So now what we need to find is we need to find the L2 so that kita boleh tolak dengan unstretched length 1.5 meter. and then we can get the value of S2. So L2 ni yang mana? L2 is this length lah. If you look here, this is L2. Okay, this is the length of the spring, L2. Right, so this is what we want, and to get that we can apa ni extract a triangle also lah. So saya lukis ke sini. This is L2, right? This is our L2. Okay, to get L2, we can extract a triangle. Okay, like this. This is the side of the triangle. And this is the top side. Okay. So we can extract that triangle like this. Right? So this is L2 as the hypotenuse. Okay. This is 90 degrees over here. Do we know what is the top side?
2.
2 meter. Okay. This is the length of the rod. And do we know the left-hand side?
3.5.
3.5. Okay, 3.5 because 1.5 here and 2 meter is the 2 meter length of the rod. So 3.5 over here. Okay. So straight away we can calculate L2 by using the theorem Pythagoras lah. L2 is then 3.5 square plus 2 square and then you square root it. Okay. So we can get the value of L2, 3.5 square plus 2 square and square root. So you get 4.031. That is L2, 4.031 meter. Okay. So therefore, S2 is L2 minus unstretched length. So we know unstretched length is 1.5 meter. So S2 is 4.031 minus 1.5. So you will get minus 1.5 here. We'll get 2.531. 2.531 meter. That is S2. Okay. S1 equals to 0. So we can go back to this spring equation. Equal to minus 1 over 2 times K. K is unknown, remember. K yang kita nak cari sekarang ni, kita punya interest is to find what is the value of K. Multiply with S2, 2.531 square minus 0. S1 is 0. So you get here US is 2.531 square. Okay, and then divided by 2, we have minus 3.203 K. Okay, K is unknown here, right? 3.203 K. Okay, K is unknown. Okay, so we have the two work done. We have the kinetic energy, T1 equals to 0, T2 equals to 0. We can then go back to this equation of principle of work and energy. All right, so let's get to this equation. T1 equals to 0 plus we have 58.86 and then minus 3.203 K equal to 0. Okay, and therefore here we can get the value of K is equal to 58.86 divided by the value of K divided by 3.203 is equal to 18.38 lah. 18.38 Newton per meter. That is the value of K. So this will be the final answer. Okay, so what I'm showing you here is that normally soalan untuk subtopik ini adalah you need to calculate the omega, but sometimes the question can be changed. Maybe the omega is given and what you need to find is the value of K, the spring constant. That can also happen lah. Okay. Any question on the last example that I want to show today before we end the class? Do you have any question? Okay, if there's no question, I will share the recording of this class in the group later. Remember, on Wednesday, we do not have class. And also, I have uploaded the assignment number 2 in Kalam. So you can do that during the class time on Wednesday. Yes, Isaac, you have a question?
In the previous example for the angular velocity, is it
Yes.
radians per second or radians
Oh,
per
sorry.
second square?
Radian per second. This
Right.
is a mistake. Radian per second square is for alpha. Okay. For angular velocity is radian per second. Okay, radian per second. Any more question? Okay, so if there's no question, remember this week you need to finish assignment number 2 and submit in Kalam. On Wednesday, we do not have class. I will do a replacement class probably this week, Friday night, but I will inform again in the WhatsApp group. Monday, we have class as usual. Wednesday, we have class as usual, and we will do quiz number 3 Wednesday next week. And Thursday night, you will have test 3 lah. So that will be the end of the course. And we also will have assignment number 3, which also I will upload in Kalam for you to do maybe during the study week lah. Okay, if there's no more question, thank you for coming to the class this morning. I will see you again online, maybe on Friday, and we will see each other face to face next week, Monday. Okay, Assalamualaikum and have a good day.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Terima kasih tuan.
Thank you, sir.
Thank you, sir.